right, great. I'm Nicole Spartano. I'm going to talk about the continuous glucose monitoring project in Framingham. So this is a technology with a thin sensor that slips under the skin and measures glucose in the interstitial space every 5 minutes over the entire wear period. We ask participants to wear this device for a full 10 days. And this technology is really designed for people with diabetes to help them manage this condition. But we were curious about whether we could identify glucose patterns in individuals without diabetes that might predict future diabetes. Of course, this was the I think, most interesting question, but it takes years of follow-up, and we just finished collecting the data. So I'll talk through some of our first projects, and we're really at this initial stages, collapsing all these, over 1,000 data points for each participant into very simple CGM metrics. So you can see here for this group of participants, these are the group of participants that have the highest glycemic burden that we defined by the amount of time they're spending above certain ranges. They also have the highest variability. You can compare that with other groups of individuals. Again, these are I'm only going to show data from participants without diabetes for this talk. Those with low burden and low variability, then those with only high burden, or only high variability, only high burden, and then both. And you can see it's really these red and brown groups, those with higher glycemic burden, that also have higher blood pressure, higher triglycerides, and lower HDL. They also tend to have higher fasting blood glucose. But you can see that even when you adjust for things like fasting blood glucose, age, sex, BMI, that those two high burden groups still have higher cardiovascular disease risk scores. And so how do these simple classifications compare to traditional glycemic classifications of prediabetes versus normal glycemia? Here, I just want to point out that this group in purple here at the bottom are actually participants that have more than one traditional glycemic trait. And you can see that almost all of those participants are also classified as this high burden, high variability grouping using CGM. And I think most intriguingly for us with this figure are that individuals in this blue group that have normal glycemia by traditional characteristics are actually falling into this high burden, high variability group. So it's a question about, it raises the question about whether there's hidden dysglycemia that we may be able to pick up, even using these very simple CGM metrics. And this next slide is really just a teaser because of this 4-minute time period, but the concept that we can use, we can leverage the more than 1,000 data points for each participant in projects like this one that we're doing, using functional data analysis to pick up different patterns of postprandial excursions. You can see there's sort of 3 different patterns here on the left depicted by the blue line, showing some people have early rise, some people rise a bit later. And I think this is really just a tease for the type of work that we're hoping to do and would love to collaborate with. And of course, this takes a huge team. I just want to shout out 2 PhD students who did most of the work that I'm up here presenting, and one of whom is in the audience, Bahar. So come bug her if you have good questions. Thanks.